Ladies and gentlemen, in the last class, we had done combinations on distinct items. Now in this class, a bit of an impromptu class as it is. I'm not well, so I'm at home, and hence thought that instead of wasting time, we organize this class. And so here we will be learning the next that comes in line, that is identical combinatorics, or rather, as they say, identical combinations. We will be understanding basically identical combination, how it is different from distinct combinations that we have already learned, and we are going to do a few problems as is customary on the above. So chalo, let us start. Now, identical combination is that topic of combination wherein the items from which we select are identical. I hope you remember what combination is. NCR is the symbol, is nothing. It represents nothing else but the number of ways in which R items can be selected from N distinct items. Right. So that is NCR. But then if the items themselves are identical, things change. So let us go ahead and understand this. The first question that we will connect ourselves is, say this one. In how many ways can I select 3 items from an option of 5 distinct items? All of us know right now that the answer is 5C3. Okay. And how are you going to solve it? I hope you remember. You first see whether the right-hand side is more than half of the left-hand side. In this case, it is. So what you do immediately NCR is equal to NCN minus R. So that gives it 5C3 is equal to 5C5 minus 3, that is 5C2. And because 5C2 right hand side there is 2, so the answer, the numerator of the answer will have the last 2 terms of factorial 5, that is 4 into 5. And you divide this with factorial 2. Why? Because 2 is on the right hand side. So you divide it by factorial 2. Factorial 2 is 2, it cancels 4, and the answer is 10. Though, of course, by this juncture, I am sure that all of you remember directly that 5C2 is nothing but 10. Well, the short story is that the answer to this is this. But notice here, now instead of 5 distinct items, it is 5 identical items. So what can be the answer here? Well, I can already hear many of you are saying that the answer is again 5C3. No. Let us understand it by a small example. Say suppose there are 5 identical, say black balls. They're absolutely identical and they're placed like this on a table or something. Suppose you are on this side and I am here, and you cannot see the balls. There is a barricade. You cannot see which ball I am selecting. Okay, that's a wall sort of a thing. Now you ask me, sir, give me 2 balls. Well, I chose these 2 balls for you and showed them to you. What are you going to see? 2 identical black balls. Okay. Suppose you asked that, oh, sir, show me 2 other balls. I showed you these 2. I have indeed shown you a different set of balls, right? But then when I bring it up in front of you, what do you observe? Arey, sir, you only are showing me the last 2 balls. Kyuki, these 2 and these 2 are identical. So you are not understanding the distinction between them. Even though they are distinct, I can see that. Because in the first case, I had selected the first and second ball. And in this case, I have selected the third and fourth ball. And Had I selected this ball and this ball, say the second and the fifth ball, and showed them to you, you would still have seen these two balls like this, and you would have thought that I am showing you the same two balls as before. Moral of the story. In how many ways can I select three items from an option of five identical items? In the eyes of the beholder, it is just one way. Because whichever two balls I give you, आपके लिए, they are the same two balls. I hope you understand. Now, instead of three items, say suppose had thus to two items. Aha, sorry, there are three items and I showed you the example with two items. So I had, my apologies. I have shown you the example with two items. Select two items from an option of five identical items. Because I was doing 5C2 here, I went on to explain two. But nonetheless, let us now do 5C3. So whichever three items I may have shown you, it will always appear to you that I am showing you the same three items. So for three items also, it will be one way. One item will also be one way because whichever ball I may be showing you, for you it will appear that the same ball is being shown to you. ठीक है ना? Whereas mind it, in these cases, the vis-a-vis for distinct ones would have been 5C2 ways, 5C3 ways, 5C1 ways, right? Had you asked me that in how many ways I can select five items from an option of five identical items, well, in this case, both the cases would have been one. Obviously, here it would have been one way. And here also, for distinct items also, it would be 5C5, which is one way. Okay? So apart from when you are picking up all the ones, you're selecting all of them. Remember, there's a distinct difference between distinct items and identical items. Identical items can always be selected only in one way. This is education number one. I hope you have understood. Now let us understand the next cases by four examples. Let us do some case studies. The first case study. See what has been written here. Now these are a cut above what you are doing. So pay attention, everybody. In how many ways can I distribute 10 identical marbles? So you have 10 identical marbles. Let us try to draw somewhat of that. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And suppose we are going to distribute this among three boys. You see, these are the three boys by which we are going to distribute. Let's name them A, B, C. Take care. But there is a criteria. A boy may not get a marble. Now, first, let us understand what this criteria stands for. Okay, let me ask you. A boy may not get a marble. So the distribution among the three boys, is it possible that they get, say, 4, 5, and 1 marble each, A, B, and C? Is it possible? The answer is yes, it is possible. See, they have said may not get a marble. They haven't said that they must not get a marble. ठीक है ना, a boy. So this is possible. None of them have got, all of them have got a marble. Okay? There is nobody who has got nil marbles. So highly possible. The next question. Is this possible? Say this distribution amongst ABC. Yes, highly possible. See, a boy may not get a marble. See, number B, boy B hasn't got a marble. So this is also highly possible. Okay, next. Is it possible that such a scenario has happened? The answer is yes. Many of you will argue that it is said a boy. But remember, in English, a boy and one boy are different. One boy means one boy only. A boy means I mean, it can be two boys also. ठीक है ना? Two boys also may not get a marble. कोई बच्चा को marble नहीं मिला. That's the translation sort of thing. Okay? So a boy may not get a marble. ये भी possible है. Now the final case. Is this possible? The answer is no. Because 4 plus 3 plus 2 is 9. But you will have to distribute 10 identical marbles. See, in all the other cases, the summation is 10. I hope you can see. Whatever be the individual doesn't matter. As long as the summation is 10, they are okay. But this is not okay because the summation is not 10. You have to distribute 10 identical marbles among these three boys. So I hope, ladies and gentlemen, first of all, the idea that a boy may not get a marble is clear. Now let us get on to the task of distributing these 10 identical marbles among these three boys so that a boy may not get a marble. How to do it? Well, one way is possible. Let us see. See now, A, B, C. These are the three. Let us do one thing. Let us distribute 0 marbles to A. Mandatory. And baki 10 let us distribute amongst B and C. How is this possible? See now. 10 is distributed amongst B and C. So it is highly possible B gets 10, C gets 0. B gets 9, C gets 1. B gets 8, C gets 2. B gets 7, C gets 3. B gets 6, C gets 4. B gets 5, C gets 5. And I'm not writing the rest because the rest will be just a reversal of this. Right. So this is one way of distributing. See, I have sidelined A with 0 marbles and ye 10 marble I have distributed among B and C. So in how many ways is this possible? Okay. Let us suppose this, first of all, mind it, we can find the number of ways, but we are not going to find it right now because that's a bit cumbersome and it's a wastage of time. Let us assume that this is done by, say, suppose M ways, by X ways. Let us take it as X ways. Suppose X ways. Now, all of this fulfill the criteria that 10 identical marbles are distributed among three boys so that a boy may not get a marble. I hope you understand. See this red portion? See, everything is actually fulfilling that criteria. Well, having done this, I can also say that chalo, A, B, C. So let us do A, let us sideline A by giving him 1 marble. And the remaining 9 marbles let us distribute amongst B and C. Highly possible. How many ways is that possible? In how many ways can I make that possible? See, B is 10, C is 0, B is 8, C is 1, B is 7, C is 2, B is 6, this is 3, B is 5, this is 4. And because this is B plus C is odd, so both of them can't be similar. The next would be reversal of these rules, right? Once again, let us assume the number of ways. By the way, I can hear that you said that how can we calculate the value of X? See, 0, 10, 0. This can be arranged, right? Because it is not only mandatory that A will be sidelined. It could have, B could also have been sidelined with 0. C could also have been sidelined with 0. This methodology indicates that. So in how many ways can this arrangement be done? See, factorial 3 divided by factorial 2. I hope you understand. Correct? So this is by this. Now this is 091, right? So in how many ways can this be possible? See, all three are distinct. So this is factorial 3 ways. This is 082. So this can be done in factorial 3 ways. This is 073. This can be arranged in factorial 3 ways. This is 064. This can also be arranged in factorial 3 ways. This is 055. This can be arranged in factorial 3 divided by factorial 2 ways. You simply add these up, and that's the value of x. I hope you got that. But this is not necessary as of now to understand this. So that's why I did not find out the exact value. Now here also you could have done that. See, first tell me, in how many ways could this be arranged? Now you see, all of you are telling that this could be arranged in factorial 3 ways, but I will say no. This has already been repeated. Look at this. The factorial 3 ways here is covered by this, right? So this is null and void. Now the next one. Now this has not been repeated before. So this can be done in factorial 3 by factorial 2 ways. This can be done in factorial 3 ways. A is 1, so 163. This can be arranged in factorial 3 ways. And this can also be arranged in factorial 3 ways. Let us not forget that 9 is an odd number, so identical distribution cannot be possible. So if you add these up, you will get the actual value. In the meantime, let us assume it as y ways. Correct. Likewise, we can say A, B, C. Let us sideline A by giving him, say, 2 marbles. So 8 marbles are distributed by B by and between B and C. How? Now see, 8, 0, 7, 1, 6, 2, 5, 3, and 4, 4. Here this identical happened because 8 is an even number. Now you see 280. Not possible. You know why? Because you see 280 has been covered here. Right? 082, remember factorial 3 have arranged it. One of the arrangements is 280. Now 271. In how many ways is this possible? Well, this is not possible because 271 has already been covered here. If you notice 172, the arrangement is 271. Okay, so 262, this has not been covered, this arrangement. So factorial 3 by factorial 2, 253, factorial 3 ways, 244, factorial 3 by factorial 2, sorry, factorial 2. Add these up. The summation will give you the actual number of arrangements. Let us in the meantime assume it to be Z ways. And carrying on like this, we will reach a scenario where you see we sideline A by giving him all the 10 marbles. Okay, we give A all the 10 marbles, and so hypothetically speaking, we distribute 0 marbles among B and C, which can be done only in this ways. So what is the total? Well, this is not possible because this has already been repeated here. You see, 0, 10, 0 and 10, 0, 0. They are the arrangements of the same thing. But for the sake of parity, let us assume that this is, say, P ways, where P is 0, mind it. But we have taken it. So these are all the ways. So we can jolly well say that the total number of arrangements is X, the ways in which it can be distributed. The total number of ways in which 10 identical marbles can be distributed among 3 boys so that a boy may not get a marble can be said to be X plus Y plus Z plus a dot 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 and ends with P. And mind it, ladies and gentlemen, this would give us the absolute correct answer. But I know what you all are thinking. This is impossible to do in an exam hall. And especially if, say, suppose there were 45 marbles to be distributed among, say, 6 boys. It's hell. This is a long cut method. Cannot be possible. But then I hope you got the depth of it, the inside story of what happened. Now the question arises, if this comes in an exam, what are we supposed to do? Now there you use your common sense. And ladies and gentlemen, this common sense is not restricted to only exams like competitive exams like the CATs and the bank POs and all the other stuff. The UPSC exams and all the top level exams, this common sense is absolutely embedded. It is useful for a shortcutter, because whatever be the level of the the competitive exam, a shortcutter will always have an advantage. So how do we do it? Now let us understand this by an interesting story. See now, say suppose this is a classroom. You see, this is a classroom. You are looking at it from the top, and you see these are the students sitting at their chairs. You see these are all students sitting, and this is me sitting at the table with the board behind. And I feel frustrated, and I just want to say, "Ki, Arey, what a bad classroom." What is the simplest way that I can divide this classroom into two parts? So that maybe I take the class of half the part and the rest of the half part is taken by somebody else. What's the easiest way? Many of you will say, okay, count the number of boys, move them to another room, blah, 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 all different things. But you see, look at it from a layman's point of view. The easiest way is, well, phone ghumaunga. I will call a plywood wala, tell him to bring a big plywood. Plywood, big, ये sort of a false wall, and लाके धक इधर रख दो. You see, it got divided into two classes. Getting the feel of it. Now, what does this imply? See, these are three boys. Now, how can you separate these three boys? What do you need to separate these three boys? You need two plywoods. You see? Hai, all the three boys are separated. So you order, phone ghumao, call the plywood shop and tell them to provide two identical plywoods by which you can separate the boys. Mind it, if there are three boys, the plywoods required are 3 minus 1. Correct? That is 2. So see, the two plywoods have reached. Okay. Now my answer would be, arrange this 10 identical marbles and these two identical plywoods. Now you will ask why. See na, suppose one of the arrangements is, look at this. I will be changing it. So I'll be rubbing this up. Say one of the arrangements is, see, one plywood here and the plywood here. See, nothing is, these marbles, even if they change places, they are identical. So they all look the same. So isko badal ke koi fayda nahi. ठीक है ना? But these two plywoods, because of their, what shall I say? Because of their ranking from the left, positional ranking, they become distinct. So see, one of the cases arrangement might be this. Now plywoods, what do? They divide. Two plywoods will divide into three parts. So you see, one boy will get 2, the other boy gets 5, and another boy gets 3. Say suppose instead of this, maybe one of the arrangements is somewhat like this. See, this could also be an arrangement. No problem. One of the boys got 9, the other boy got 1, and the other boy got 0. Correct? Instead of this, say suppose one of the arrangements were like this, both the plywoods together. No problem. One of the boys had got 5, one of the boys got 0, and the other boy got 5. Correct? So basically, the arrangement of these marbles and plywoods, the number of ways they can arrange, will tell you the number of ways you can distribute. And where 0 is definitely allowed, you see another case where 0 can be a part is maybe say one of the arrangements can definitely be like this. So well, this is one boy has got 10, another boy has got 0 and the other boy has got 0. ठीक है ना? So let us find out in how many ways they can be arranged. We all learned that in the last class. The number of ways in which 10 identical marbles and 2 identical plywoods can be arranged is factorial 12. 10 plus 2 is 12. Divided by, because the 10 marbles are identical, factorial 10 into factorial 2. For those who can't remember, remember my example of blood. In how many ways can you form English words with this? Right? So the answer would be how many ways can you form English words with this? Factorial 5 divided by factorial 2, because O and O were identical, remember? So similarly, 10 identical marbles, 2 identical plywoods, how many ways you can arrange them is factorial 12 by factorial 10 into factorial 2. And believe me, this is the answer. But the student said, Arey sir, what does it look like? Show some parity. How do you remember? How do you know? So I will say, Aja, what does this look like? What do you think factorial 12 by factorial 10 into factorial 2 is? Isn't it 12C2? 12C2 is nothing but factorial 12 divided by factorial 10 into factorial 2. Yes or no? ठीक है ना? I hope you understand NCR is equal to factorial n divided by factorial n minus r into factorial r. So that is 12C2. Now you are going to ask me, sir, from where did 12 come and 2 come? I will say, Arey, how many marbles were there? You will say 10 marbles. I will then ask you, how many boys were there? You will say 3 boys. I will then ask you, well, then how many plywoods are needed? You would say 3 minus 1 plywoods. I will say, Acha, take them together and from them select the number of plywoods. The number of plywoods is 3 minus 1. So this is from where you get it. And you see, for all the engineers out there, I mean, all of you are engineers, for all of you out there, you see, this is what you learnt by heart for so many years without actually understanding what it was. N plus R minus 1, C R minus 1 ways. This is the history behind it. And it's nothing but plywoods. I hope you understood. This is the shortcut. Is that clear? Right? So let me give that to you in an abridged fashion. So you see the whole screen is clear. Okay? The long cut part in blue, the understanding part in the pinkish color, okay, and the actual realization in the green. You will use the green part because now you are educated enough to understand all the plywoods and marbles. You are not going to use the same plywood and marble every time. Okay, na? Now that you have understood it. Clear? Let's move on to the next. The next question. The next case, rather. In how many ways can I distribute 10 identical marbles among 3 boys? So those 10 identical marbles are still there. I hope they're 10. 1, 2, 3, 4, 5. Yes. And these 3 boys are still there. The boys are ABC. This time the criteria is a boy gets at least 1 marble. Now what does at least 1 means? It means a boy can get 1, a boy can get 2, a boy can get 3, blah, 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 blah. A boy can get 9, a boy can get 10. Can't get more than 10 because total 10 marbles are there. One point is certain. A boy can't get 0. So what's the best way to do this? Now, for a long cutter, this will be a severe long cut. ठीक है? Because you see, this was the bluish one was the long cut when a boy could even get 0. Now, when a boy couldn't get 0, so this 0 giving anything to 0 will vanish. And this, even 10, cannot be distributed by 10, 0. 9, 0, not possible. So you'll have to eliminate these and calculate all the rest. That's pretty lengthy. And we have taken very rosy figures of 10 and 3, 10 marbles and 3 boys. Not always will be the case. Will such be the case? Take care. This could be pretty jolly 30. This 3 could be in 13 boys. So there we will be in dire straits. So we will have to find out a process for whatever the figures, we are absolutely okay with it. So how do we do that? Two ways. We already know of the plywood theory. We know the plywood theory when we were placing it. Remember this pink wala portion? We had taught ourselves that you see on the position of the plywood, this will happen, right? So we can think of that. We have ordered 2 plywoods as usual, right? They are placed here. Now, how will this plywood be placed? Well. We cannot allow 0. So one thing is for certain. The plywood cannot be placed at the ends. Because देखो अगर एक प्लाईवुड भी एंड में बैठा, say suppose this were the thing, so this means 3, 7 and 0. So this 0 will come in. Moral of the story, a plywood cannot be placed at the ends. So that is the first thing. The plywood is not to be present at the ends. And the second thing is, both the plywoods together cannot occupy the same vacancy between the marbles. Because the moment both the plywoods are here, a 0 crops in, right? So that we cannot allow. So how are we going to do that? Well, we can jolly well say that see, what are the positions wherein our plywoods can be positioned? So we will say there are 10 marbles. So the total number of vacancies, including the extremities, will be 11. But both of these are gone, na? They are not there. So now the number of vacancies will be 9. See 1, 2, 3, 4, 5, 6, 7, 8 and 9 vacancies. So इस 9 वैकेंसी में कोई भी 2 वैकेंसी एक एक प्लाईवुड ऑक्युपाई कर लो. Not the single vacancy by 1, 2 plywoods. 2 vacancy, 2 plywood occupy कर लो. So how do you do that? The number of ways you can select 2 vacancies out of 9, which is 9C 2 ways. The number of ways you can select 2 vacancies. 2 vacancy क्यों? Because in one, there will be 1 plywood. In the other, there will be the other plywood. The plywoods cannot be together in the same vacancy. And why 9 vacancies? Because the plywoods can't be positioned at the extremities. So this will give you your answer. This is one way. But the more user-friendly and the methodical way would be go back to this greenish part, the thought process, you see. The plywoods are arranged. Plywood divides everything into 3 parts, 2 plywoods. So that way, factorial 12 by this, and this is the, remember this part? So we can say, acha, now every boy has to receive at least 1 marble. तो एक काम करते हैं ना. Let us first select 3 marbles. Come on, in how many ways can you select the 3 marbles? Out of 10 identical marbles. No, not 10C3. One way. Identical. Right? Only in one way. So you have selected the three marbles in one way. Now, how do you distribute these three marbles? माने मेरा एम है हर बंदे को एक एक मार्बल दे दो. 3 मार्बल है तुम्हारा हाथ में. You have 3 marbles in your hands. Give 1 marble each to the boys. Don't forget the marbles are identical. So the next job is give 1 marble to each boy. In how many ways can you do this? See na, imagination. I can say na, le, फेंक दिया. I threw it. So I pick it up, 1 marble each. So how many ways? Only one way. My activity is what? Throw. Only one activity. So I do that activity also, simultaneous activity. So rule of multiplication. Okay, 1 into 1. And now how many marbles do I have? How many marbles I have? I have now 10 minus 3, 7 marbles, correct? So my next job is distribute 7 marbles among 10 boys so that a boy may not get a marble, may not get a marble, which is exactly as the last case. किसी बच्चे को मार्बल ना भी मिल सकता है. You distribute these 7 marbles among 10 boys so that a boy may not get a marble. And how do you do that? 7 plus how many plywoods? 3 minus 1. C. 3 minus 1. Yes or no? So simultaneously वो भी कर लो. 7 plus 3 minus 1. C. 3 minus 1. And that is equal to 1 into 1 into 9C2. That is 9C2 is. So see the thought processes. That's the most important thing. I hope you understood. And now you see both of them together. How this was derived from this. 2 ways, 1 way and the second way. This was the second way. Okay. Right. Let's move on to the next. In how many ways can I distribute at most 10 identical marbles? Tell me first of all, what does at most 10 marbles mean? What do you mean by at most 10 marbles? At most 10 marbles means, अगर if I say कि मेरा पॉकेट में at most 10 marbles है, इसका मतलब क्या है? इसका मतलब मेरा पॉकेट में 10 मार्बल हो सकता है, 9 मार्बल्स हो सकता है, 8 मार्बल्स हो सकता है, 7 मार्बल्स, 6 मार्बल्स, 5 मार्बल्स, 4 मार्बल्स, 3 मार्बल्स, 2 मार्बल्स, 1 मार्बल और 0 मार्बल्स भी हो सकता है. सब कुछ पॉसिबल है. एवरीथिंग इज पॉसिबल एक्सेप्टिंग 10 मार्बल्स एंड अबव. सॉरी, एक्सेप्टिंग 11 marbles and above. ठीक है? At most 10 marbles, I hope you understood. Among 3 boys, so that a boy may not get a marble. How do you do this? Now I can't draw 10 marbles because I may not have 10 marbles with me. ठीक है ना? So I can't draw the marbles. I only know कि भाई these are the 3 boys. ठीक है ना? And they don't even know कि how many marbles are going to be distributed amongst them. Right? So how to do this? No problem. A student said that ये तो easy है. You see ना. First case, you distribute 10 marbles. I'm writing it in short because space is less. 10 marbles among 3 boys. Criteria. a boy, so that a boy may not get a marble. So that will be done in 10 plus 3 minus 1 C 3 minus 1 ways. We already studied this in case 1. Next, at most 10 बोला है तो 9 marbles भी possible है. तो 9 marbles 3 boys में distribute करो, so that a boy may not get a marble. That will be possible in 9 plus 3 minus 1 C 3 minus 1 ways. तो फिर 8 marbles भी possible है, because 8 marbles at most 10 marbles का अंदर पड़ता है. It falls in within that. So distribute amongst 3 boys. Same criteria. So the answer is 8 plus 3 minus 1 C 3 minus 1 ways. And I say dot 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 dot. Last, what will be the 10th case? 0 marbles. So distribute among 3 boys, so that a boy may not get a marble. This is merely a paraphernalia, but I hope you can see. So that will be done in 0 plus 3 minus 1 C 3 minus 1 ways. And finally, what you do is you add all of these up. Taina. So you will get the answer. It's pretty nice. But just imagine you have 45 marbles and 7 boys. So there will be a list of 45 things which you will have to add after finding the value of each of them. That's absolutely impractical in an exam. So what do you do? Now here, this is very interesting. Let us go back. Many of you might have wondered, I don't know, nobody said it, कि सर जी, why are you doing all this blue वाला nonsense? ठीक है ना? अच्छा देखो ना, इसको स्टडी करो. What is happening here? Tell me, in this case, what was being done? Well, in this case, 10 marbles were being distributed among 3 boys, so that a boy may not get a marble. Tell me yes or no. And the result was exactly as 10 plus 3 minus 1 C 3 minus 1. This same result would be X actually. Okay. Sorry. This was not distributed among 3 boys. My apologies. This was distributed among 2 boys, so that a boy may not get a marble. So what resulted was 10 plus 2 minus 1 C 2 minus 1. That's exactly what happened. Hannah, see, 10 marbles were distributed on 2 boys. Well, what happened in this case? See, in this case, what happened was 9 marbles got distributed among 2 boys, so that a boy may not get a marble. And the result was 9 plus 2 minus 1 C 2 minus 1 ways. What happened in this third case? Mind it, they are the solution of a completely different sum. But look at what we have done unknowingly at that point of time. We have distributed 8 marbles among 2 boys, so that a boy may not get a marble. And the result is 8 plus 2 minus 1 C 2 minus 1. And dot 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 dot. Finally, what did this happen? Finally, what happened was we had distributed 0 marbles among 2 boys, so that a boy may not get a marble. And the result was 0 plus 2 minus 1 C 2 minus 1. Yes or no? Tell me. That's exactly what we did. We distributed 0 marbles among 2 boys. We distributed 8 marbles among 2 boys. We distributed 9 marbles among 2 boys. We distributed 10 marbles among 2 boys. That's exactly what we did. And yet, when we added all these values, what was the answer that we got? We got the answer of exactly 10 marbles distributed among 3 boys. Criteria so that a boy may not get a marble. This was the answer that we achieved from their addition. Now tell me, what does these represent? Doesn't these represent together at most 10 marbles? Doesn't they represent at most 10 marbles? They do, right? 10 marbles, 9 marbles, 8 marbles, 7 marbles, 6 marbles, blah, 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 0 marbles. So what do we find? At most 10 marbles distributed among 2 boys so that a boy may not get a marble is exactly equivalent to exactly 10 marbles among 3 boys so that a boy may not get a marble. Both of these values are equal. I hope you got it. At most 10 marbles among 2 boys. Criteria is the same. A boy may not get a marble. Will always be equal in value to that of exactly 10 marbles among 3 boys. The criteria is the same. A boy may not get a marble. Yes or no? So what do? We use our common sense. And we say that, acha, the answer to this, which has asked me at most 10 marbles distributed among 3 boys so that a boy may not get a marble. ये पूछा गया है, this has been asked for, must be equal to exactly 10 marbles distributed among 4 boys, so that a boy may not get a marble. Yes or no? और इस माने एक फिक्टिशियस बच्चा पैदा कर लिया हमने. So this value we know very well from case 1. It is 10 plus 4 minus 1 C 4 minus 1. And this is the answer for this. A super shortcut. See your brevity of thought. The actual answer, and in many places, in many books, you will observe that it is actually done by this blue part. It's actually solved by this blue part. But no, we won't, because we are in competitive exams. One question in exams like, in campus recruitment exams, less than a minute. In CAT and other exams, around 2 minutes to 3 minutes. And in UPSC and other exams, around 1 minute to 2 minutes. Okay, we can't afford that. So we have to think unlike others. We have to use our common sense. And this is as best common sense as is possible. I hope you have got it. The next. In how many ways can I distribute at most 10 identical marbles? So once again, I can't draw the marbles. Only thing that I can draw is among 3 boys. So these 3 boys are there. Okay. They are these 3 boys, A, B, C. Such that a boy gets at least 1 marble. So what do we do? Chalo, at most 10 identical marbles. So I hope you realize that in this at most 10 identical marbles, one case is highly possible that they have 2 marbles. 2 marbles. 2 marbles falls within at most 10 identical marbles, right? So they have 2 marbles. But tell me, is that actually possible? No, na? Because if each boy has to get one marble and there are 3 boys, how will it be possible? It is not possible. So understand that 0 marbles is not possible, 1 marble is not possible, 2 marbles is not possible, but 3 marbles is possible, 4 marbles is possible, 5 marbles is possible, blah, 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 blah. 9 marbles is possible, 10 marbles is possible, more than 10 not possible, because at most 10 identical marbles has been asked for. So this fact has got to be understood. So I know that the number of marbles is from 3 marbles to 10 marbles, which is to be distributed. Ab samjho, a boy gets at least 1 marble. So let us use this thing. Let us select 3 marbles in one way. Give 1 marble to each boy in one way. And then you will have -3, whatever was there with you, -3 marbles. Let us follow this part. So chalo, let us do it. Now, one thing I am sure you are also understanding the moment I have said it, if you are actually thinking, is that, अरे भाई 3 मार्बल अगर तुम्हारे पास है at most 10 marbles में, and you give away 3 marbles to the 3 boys, now you are left with 0 marbles. This 3 means 0. तुम्हारे पास अगर 4 मार्बल होता, if you had 4 marbles and you have given 3 to the boys, you will be now left with 1 marble. तुम्हारे पास अगर 5 marbles होता and you had given 3 marbles to the boys, you are now left with 2 marbles. Dot, 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 dot. Actually, if you had 10 marbles and you had given 3 marbles to the boys, you would be left with 7 marbles. So, I select 1 marble in one way. My apologies. I select 3 marbles. I select 3 marbles in one way. I distribute 1 marble to each boy. Remember I told you, throw them, they're identical marbles, one activity. So another one way. Rule of multiplication, because both of them are done simultaneously. So 1 into 1 ways. And now you are left with 0 marbles to 7 marbles. Correct? So basically this is at most 7 marbles. Please understand, 3 marbles to 10 marbles cannot be called as at most 10 marbles. Even though here it is said at most 10 marbles, identical marbles, we know that these 3 can't be possible because of this criteria. Each boy gets at least 1 marble. So technically, at most 10 marbles was not the actual case, because it started from 3, not from 0. But after you have given 3 each, now it is at most 7 marbles, right? No problem. So you create a fictitious boy. You know this, how to do this? The last one, right? At most 7 marbles distributed among 3 boys would be equal to exactly 7 marbles to be distributed among 4 boys. So you say that at most 7 marbles among 3 boys, so that a boy may not get a marble. I'm not writing that every time. Will be equal to exactly 7 marbles among 4 boys, so that a boy may not get a marble, whose value is 7 plus 4 minus 1. C, 4 minus 1, right? So this will also be simultaneous activity and will be done along with. So that will be the product. And hence the answer would be 7 plus 4 minus 1, C, that is 10, 10 C3. And you have got your answer. Shortcutting at the extreme. Okay? Concept. Understand these concepts. I hope you are getting it. Right. Okay. Let us now do some examples. Let us solve some problems. See, we have 6 problems. We'll be doing these 6 problems. The problems are pretty classy, mind it. I throw 4 dice simultaneously. Pretty common also, right? I mean, they have appeared in a lot of UPSC, in a lot of even joint entrance exams, IIT exams. This was an IIT, Indian Institute of Technology entrance exam. Okay. It also has found its appearance once in a CAT exam. Okay. So the questions are all of the same type. And how do you do them? I throw 4 dice simultaneously. So you see dice, I hope you understand, Ludo wala. So see 4 dice. You have thrown 4 dice simultaneously. In how many ways will the total show 7? How do you do that? In how many ways will the total show 7? Now, one thing is for certain. You can think of this in a lot of ways. Oh, chalo, let this die show 1. So what these dice can show? Blah, blah, blah. That's a very lengthy affair. One shouldn't do that. I will not be that elaborate because the theories are over now. Now you'll have to, connect them. So I can imagine 7 to be 7 dots like this, right? 7 dots like this. ठीक है ना? So these 7 dots are to be distributed among these 4 dice, right? But remember, a die cannot, can there be a die possible which has 0 dots in it? I mean, what are these dots? By the way, see in a Ludo, see one die, see वो 5 पड़ा ना बोलता है ना 5 पड़ गया. So it's something like this. So this has 5 dots. So 5 dots fell. So 5 dots were occupied by this die. Something like that. Okay, I'm rubbing this off. So what they have basically asked is that this total will be 7. But none of them can have 0. So काम करो. Select 4 dots. You can select it in one way. Dots are identical, right? Distribute these 4 dots among the 4 die. कैसे? फेंक दो dots. उठा लेगा. So another one way is, right? Simultaneous activity. बचा कितना है? 3 dots. So distribute these 3 dots among the 4 die so that a die may not get a dot. And that is possible in how many ways? See, 4 die will require plywoods. How many? 4 minus 1. So 3 plus 4 minus 1. C 4 minus 1 ways. That's your answer. I'm sure you can see that this is 1 into 1. That is gone. So this is 6C3. All of you can find the answer to 6C3. 4. The next question is 4. So in the next question, these are not there. I will say Dur. 4 die to de diya, 1 into 1. And left is 0 dots. So the answer would be 1 into 1 into 0 plus 4 minus 1. C 4 minus 1. That is 1 into 1 into 3C3. That is 1 into 1 into 1. That is one way. Well, this can be done, but don't do it. ये तो common sense है यार. The only way by which you can distribute this 4 is 1 on each. ठीक है ना? So इतना करने का जरूरत नहीं था. You could have jolly well said it one way. 24. Don't even think of this. 24. The only possibility is 6 on each die. So the answer for 24 will also be one way. Okay. Now the top level question of this is number D. Okay. A question that can decorate any UPSC or an IIT question also. How do you do this? How will you distribute 21? Well, I'm rubbing this part off. Okay. Because the sums have this common space. So I'm rubbing this part off. I hope you all have got it. Plus, you can always rewind and see it. I'm sure you are recording them. So you see, 21. तो बच्चा बोला देखो there are 21 dots. तो 4 डॉट ले लो, वन वे. 4 डॉट डिस्ट्रीब्यूट कर दो, वन वे. So देखो ना, each of them has got 1, 1, 1 and 1 dot. So now the number of dots left is 17. So they say distribute 17 dots among the 4 die, so that a die among the 4 dice, so that a die may not get a single dot. So the answer would be इधर ही लिख लेते हैं. Answer would be 17 plus 4 minus 1. C, 4 minus 1. And I know what you all are thinking, that this is absolutely correct. Well, one of the cases amongst this could be this also, na? देखो 17 I distributed among 4 dice, so that a die may not get a dot. So this is also possible. तो आजकल क्या डाई में 18 डॉट्स हो रहा है? Is this possible at all? No, because you have violated the upper limit. So this time the sum is on the violation of the upper limit. Got it? How do you tackle that? Think. Coolly think. How do you tackle that? See, एक काम करो. तुमने ना पहले 24 डॉट्स distributed amongst this die. The only way of distribution is 6, 6, 6 and 6. लेकिन तुमको तो 21 डॉट्स डिस्ट्रीब्यूट करना था. क्या करेगा? You cannot take back, right? If you just observe properly, in combination by combinatorics, you cannot take back. You can give, you can select, you cannot, take as return, right? So what do? No problem. तुम इमेजिन करो, दिस इज इमेजिनेशन. तुम 3 ठो नेगेटिव पॉइंट्स पैदा करो. You create 3 negative -1 points. They are identical. और इसको डिस्ट्रीब्यूट कर दो. You distribute these. First of all, you 6, 6, 6, 6. They were possibly in one way. Now you distribute these 3 negative points among the 4 die, such that a die may not get a negative point. कैसे? 3 negative points. You distribute it among 4 die. So plywood is 4 minus 1. C, 4 minus 1. ठीक है? This will be your answer. Student said, अरे sir, what are you saying? How can this be the answer? कुछ भी. चलो ना देखते हैं. What can be the most extreme thing? तीनों ही नेगेटिव पॉइंट एक ही डाई में चला गया. See, negative points are doing their job in the die. And you see, this is very much a valid one, right? Very valid. See, 3, 6, 6, 6. The total is 17 indeed. ठीक है ना? Sorry, 17, 21. Total is 21 indeed. And all of these are valid. Now, सबसे मुलायम distribution, मतलब सबसे easy distribution क्या है? See, the easy, मैं ऊपर में लिख रहा हूं, is that तीनों में -1, -1, -1 और एक में 0. This is the most smoother distribution, right? So क्या है? Very much valid. 3 ठो डाई में 5, एक डाई में 6. Highly possible. See, the total is still 21 and very much possible. So your answer is 1 into 3 plus 4 minus 1, C, 4 minus 1. That is 1 into 6C3. And I hope you all know what the value of 6C3 is. This is a top level problem. Okay? Hope this is clear. Let's go on to the next one. Find the number of terms of the expression. See, you all know now binomial theorem. If you don't know, then you should immediately study it because it has been done. A plus B whole to the power n. What does the expansion tell us? If you remember properly, it is nc. Come on, come on. It is nc0, a to the power n, b to the power 0, plus nc1, a to the power n minus 1, b to the power 1, plus nc2, a to the power n minus 2, b to the power 2, plus blah, blah, blah. The second last one would be nc. How much? nc n minus 1 c. How much? What c? A. Sorry. nc n minus 1 a to the power 1 and b to the power n minus 1. And the last one would be ncn a to the power 0, b to the power n. This is the binomial expansion, right? So what do you observe in this? I hope you have observed before. First, that देखो nc0, nc1, nc2 करके 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 ncn it ends. Right? Okay. Now, so how many terms are there? You can say it from here only. Total number of terms, how many are there? Very nice. 0 to n, and that is n plus 1. So whenever you have two terms, you don't need to calculate. If there are two variables, so if the power is n, you will say there will be n plus 1 terms. Okay, because you see what has happened. 0 से शुरू हुआ 1, 2, 3, 4, blah, 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 n minus 1 n. So it has gone from 0 to n. So that's totally n plus 1 terms. So that is the first observation. Second observation. A ka power starts from n and ends at 0 and decreasing 1 each along the way. And B ka power starts from 0 and ends at to the power n, increasing 1 each along the way. Right? Correct? And what's the most important thing? Look at the summation of powers of variables. That is A and B. What is the summation? It is always n. See, now n plus 0 is n. N minus 1 plus 1 is n. N minus 2 plus 2 is n. 1 plus n minus 1 is n. 0 plus n is n. Understood? For this sum, mind it, here there were two terms, so you could say n plus 1. Here there are four terms. The same rule won't apply. So here you need some mathematics. And what will we actually utilize? What property? It is this one, that the summation of the powers of the variables will always be equal to n. What is n here? N is 12 here in this sum. So, a to the power alpha, b to the power beta, c to the power gamma, and d to the power epsilon, say suppose, are the variables of each term. Then remember one thing, that alpha plus beta plus gamma plus epsilon must be equal to 12. And if you notice here, the powers can also be 0. See, B has been 0, A also has been 0. Moral of the story, alpha, beta, gamma, and epsilon can also be 0. Yes or no? So what does this sum reduce to? लग नहीं रहा है अंगूठा छाप के लिए, that you see, you distribute 12 points among 4 variables such that A variable may not get a point. Yes or no? यही तो बात है. And what is this? Case number 1, right? So the number of terms would be very, very simple. It would be 12 distribute करना है among 4 variables. So plywood चाहिए 4 minus 1, C 4 minus 1. So 12 plus 4 minus 1 is 15, C 3 is our answer. The values I'm not finding out here because I'm sure you can find them. Got it? So that's the answer to question number 2. See, identical combinatorics is a very useful thing. It's very much useful in algebra, especially for the cat people. Algebra is a big thing. For cat, section C, after arithmetic, it is algebra. That's most important. And you can solve it in just like that. ठीक है, this sum solution will take you exactly 10 to 15 seconds. This is a high standard sum. Can easily walk into any IIT question. Okay. Next, how many acha, allow me to rub this off because the questions are all in one place. I hope you have understood them enough. How many numbers till 5 digits exist such that the sum of the digits is equal to 9? Till 5 digits. मतलब तुम्हारा नंबर ये भी हो सकता है 1 digit. Sum of the digits is equal to 9. Highly possible 9 itself. 2 digits भी हो सकता है. अरे 72. 3 digits भी हो सकता है 342. ठीक है ना. 4 digits भी हो सकता है. सी ना 1 2 3 एंड कितना 3. ठीक है ना. समेशन इज 9. ठीक है ना. एंड 5 digits भी हो सकता है. सी ना 2 3 1 2 और फिर क्या है 4 एंड 4 8 एंड 1. ठीक है ना 9. So all of these are possible. So how many numbers till 5 digits? So all of these types are possible 5 times. Such